Hello there, students. In this video, we're going to take a look at the flight times, maximum height, and maximum range for a projectile. For the time being, we're only going to consider projectiles that are launched on level ground, meaning the total displacement in the y direction is 0. Let's take a look at a projectile launched with some initial velocity v0 at an angle of elevation theta. It is affected only by gravity in the y direction. Because of the effect of gravity, the velocity in the y direction will change and eventually become 0. This happens at the top of the projectile's trajectory. The time it takes to get to this apex we will call time t1. This is also the highest point the projectile will reach. We will label this maximum height as h. The projectile will begin to fall, eventually returning to the ground at the same height it was launched from. The time it takes to ascend to the apex is the same time it will take to fall back down from the apex, so we can mark this final time of impact, or the total time of flight, as 2 times t1. The point of impact is the range of the projectile for the given initial velocity v0 and launch angle theta. We will call this distance capital R for range. The first thing we will do is calculate the maximum height h. We'll use this kinematic equation. When we let the initial position y0 embedded in the delta y term be equal to 0 and use our knowledge that the final velocity vf at the apex is 0, this equation simplifies a bit. Solving for the final y position, which is actually our max height h, we find it is equal to v0 y squared divided by 2g. Now, let's calculate the time it takes to get to the apex, time t1. I'll start with a definition of an average velocity, which is the sum of two velocities divided by 2. We'll use the initial y velocity and the velocity at the apex as our two velocities. We also know that the average velocity can be defined as the change in position divided by the change in time, t1. Putting it together, and knowing that the velocity at the top, vf, and the initial position, y0, are both 0, we can solve for time t1. We find time t1, the time taken to get to the apex of the trajectory, is equal to 2h divided by v0y. The last thing we need to calculate is the max range r. Starting with this kinematic equation, where we know the x acceleration is 0, and the total time of flight is 2 times t1, where t1 was just the time of flight to the apex of the trajectory. Letting the initial position be equal to 0, we see that the final x position, which is our maximum range r, is equal to the initial x velocity, v0x, times 2 times t1. Substituting in what we've previously found for time t1 and then height h, we find that the range r is equal to 2 times v0x times v0y divided by g. Using some trigonometry, we can write these initial x and y velocities in terms of just the initial velocity and some sines and cosines. The initial x velocity can be written as v0 times cosine of theta, and the initial y velocity can be written as v0 times sine of theta. Substituting those in, we now have range r equals 2 times v0 squared times sine of theta times cosine of theta divided by g. We can simplify this a little further by substituting the sine and cosine product with a double-angled trigonometry formula. You can look this double-angle formula up, or if you never want to look up a trigonometry angle formula again, check out my short video on how to use DeMoivre's theorem. The substitution says that 2 times sine of theta times cosine of theta is equal to the sine of 2 theta. This makes our final range equation read r equals v0 squared times sine of 2 theta divided by g. Now, given just the initial velocity and the angle a projectile is launched at, you can find the time of flight to the apex or impact, the max height, and the range of the projectile. Thanks for watching and learning about physics. If you have any questions or want to see a specific topic covered, leave a comment below or head over to my Facebook page.